I going to be looking at today? It's the Astable Multivibrator, or more commonly known as flip-flop. But hang on a minute, I've done flip-flops. The only trouble was I didn't really understand it. I sort of got the idea what was happening, but didn't properly understand what was actually happening within that circuit. So I'm going to have another look at that. I've spent some time trying to understand it. I think I've managed to get it. Before I'd managed to draw out a little circuit like so on the hand CAD. I've upgraded that slightly to something that's a little bit better looking. I can get that, it's on a bigger piece of paper. Obviously I put no values on it because all the values could change depending on how quickly you want it to work and what you want to get out of it. So let's have a look on the workbench and actually have a look at the circuit. Okay, so here we go. On the breadboard we've got the Astable Multivibrator. At the moment I've got this wired up so that this multimeter is looking at the positive side of this capacitor, and this multimeter is actually looking at the negative side of this capacitor, which happens to also be the base of the transistor over here. And at the moment you can see that, let's let it change state. Once it goes to red again, when it's red, this transistor's off, this capacitor is charged up, and the base is gone from negative to positive, and at the moment then it'll change, this will discharge, the capacitance will start to charge up even though the transistor is still on, and at some point it'll flip back over. So let's have a quick look at that on the actual diagram and try to understand what it's actually doing. So here we go. Here's the circuit I've drawn out. Now, 2 electrolytics, 2 transistors, some resistors, and a couple of LEDs. Now, the LEDs don't need to be there. They're just there so I can see the circuit working. But what we do need, as I've realised, is I do need this transistor, because if I wanted that to actually be an output signal to somewhere, going high and low, then I would need to have the transistor there. So obviously I've got to drop a certain amount of voltage so that there's a particular voltage at that point as the transistor turns on and off. And when it's off, it'll give me the voltage. When the transistor's on, the voltage will be sunk, which is not right, is it? That's the other way. When the transistor's off, the whole voltage is dropped across there because there's no circuit. But then you'd say, hang on a minute, there's a capacitor there, so there should be a voltage. So let's have a look at what's happening when I turn this on. When I first turn this on, both these will start to charge up. As we know from the curve for a capacitor, as we turn it on, the voltage will rise until it meets the point where it can't go anymore, and the current will drop until there's basically no current left over time. And of course that's what will happen here. The voltage will rise, but because of imperfections, one of these will charge up slightly quicker than the other. And the way I see it is that as this charges up, let's say for instance this charges up a little bit quicker, this voltage will go lower before this point because they're tied to the base. So this transistor will turn off, it'll be fully turned off. At that point what happens is this transistor, which wants to turn on and use about 0.6, 0.7 of a volt to turn on because there's no resistor to bias it on the emitter, will turn on. It'll draw the appropriate amount of voltage that it's required to turn it on, and that the rest of the voltage will be across this resistor, and these resistors are much higher than these ones. I've put in the circuit 330 there and about 2 meg ohm there on these two resistors. The effect of that is that's turned on, that's at about 0.6 of a volt. That's going to immediately discharge this transistor, this capacitor, through this transistor. And the effect there is that this side will go negative voltage and will slowly rise. This side, this is now turned off, so the capacitor here will charge and up to about 10 volts, because I've got a 12 volt power line in here, power supply. So that's charged up to 10 volts. That's at 0.6, 0.7 volts. That is discharging through there, and that's at a negative voltage. Now, these capacitors that I'm using are really large, 1000 microfarad, because I want to see the effect in sort of slow-mo. And what happens that I've seen is that actually this voltage will now rise. This will start to charge again, even though this discharge path is there. So the current is going through there, but there's a certain voltage that's increasing on that point. And on this side, the voltage is also increasing slowly from the negative to the positive, until it gets to a point where this one is now able to switch on. And when this switches on, it discharges through there, dumps the voltage that's there and the current, and at the moment it does that, it sends this to negative. So that's a negative voltage and will immediately turn this one off. So now we're in the other scenario. This is now discharging the voltage through there and the current through there, but this capacitor is now slowly charging up. This is a negative voltage, it's slowly rising. This is off, so that's charged to the capacitance that it needs, and this has switched itself on, so now it's drawing the 0.6, 0.7 volts that it requires to turn on, because these transistors, it's like they want to turn on, but they can't unless the voltage and the current that's required is available to it. So it's now discharging through this side. But what's happening is that this voltage is now rising. Now, the odd thing that I couldn't understand here is why would that be rising? But what I wasn't looking at is I wasn't looking at the current. So let's draw a bit of current on here, the current flow, so the charge that I get from the capacitors. When I very first turn it on, they both try to charge up at the same rate, but obviously one of them wins out. So let's say this one wins out. This charges up a bit quicker than this side. What we get is that this will be low. Is that right? This charges up a bit quicker, so that drives this low, turns this one off. So we get our, let's just 0.7 volt there. Right? And as it does that, it turns this transistor on, so the current that's built up, the charge that's built up there, is now going to discharge this way through the transistor. But then, because this is turned off, there's basically like a break there, it's not doing anything. This capacitor will charge up, so we get my 10 volts charging up there, and this will charge up, and it's a case of the current that can charge, that comes on the negative side of this plate, is going to come through this transistor up through there while this transistor is turned on to give me a charge on that one. But because this transistor is turned off, it's a case of what's going to happen to this charge here. It's got nowhere to go, but it has to go somewhere. That's why it drops to a minus voltage, because we've got a negative charge here which drags the voltage down, because this charge, the only place it can now go is there up to the plus voltage rail. But at the same time as this is discharging, this voltage is now increasing. And with that, as that negative charge disappears from there, this voltage will rise until it gets to a point which is about 0.25 of a volt, about a quarter of a volt, when the charge that's on this plate here is now low enough that this resistor can work in the convention that it's in a normal conventional way, that there's a plus voltage here and there's a lower, I would say, negative voltage, but it's not. It's just that it's lower because there's a potential difference now between this point and this point. And this means that the base of this transistor and this junction for the base emitter can now turn on. It's at a point where the charge is low enough that this can turn on, and it does. And when it does, it then flips the whole circuit around. And what happens is this point now becomes 0.7 of a volt. The 10 volts that was on here and the charge that built up will now be very quickly discharged through there, through this transistor. This LED will come on. But it means that this here now has nowhere to go because this transistor is now turned off. This plate will now charge up to 10 volts, and the negative charge will come through this emitter base line and put the negative charge on that one. And like I say, this one's now got nowhere to go. So what will happen? It'll now then discharge through the only path it's got left, which is there. And as you see, that will happen until the negative voltage that's now created here rises to a point of about a quarter of a volt. And at that point, it will then all flip back again to this scenario. So to me, that is the basics of why this flip-flop works, because we have to remember not the fact of the two transistors, that they're just being switched on and off, because that is what's happening, but these capacitors have the ability to hold the charge and then release it and control that charge effectively through these resistors. Depending on what I put here for these resistors and what capacitance I use will depend on how quickly it can flip-flop, it can change, it can switch on and off these transistors. And of course everything comes down to what values you use. The larger values you've used, like I've used 1000 microfarad, 2 meg ohm there, 330 ohms there, and these are BC337 transistors. You could set it up so you have a smaller capacitance, a much smaller resistance here, and transistors that switch very, very quickly. So you could actually get a very quick oscillating circuit. But to me, that is how I understand that this circuit works. And I think that is enough understanding so that that circuit becomes useful to me. There you go. So there you go, the Astable Multivibrator, or flip-flop circuit. Quite simple really. Hopefully I've gone through it well enough that I now understand it. I think so. I think I've got the fundamentals of that circuit in my brain, so hopefully I won't forget that. And if I've explained it well enough, hopefully you've understood it as well, which would be great. Astable Multi-Vibrator circuit. there you go. What can I say about it? Anyway, if you like this video, give us a thumbs up, subscribe, and all comments are welcome. If you have had a bit of trouble with this circuit yourself, then put it in the comments. I'd love to hear about it, or if you understood it straight off the bat, comments as well, please. And that's it for today. Catch you next time.